This is an example of an exam question where you have to do a hypothesis test involving the product moment correlation coefficient. So just pause the video perhaps and just make sure that you've read and understand what this question is about, and I'll press on and we'll solve it. Now, you will never ever have to calculate yourself a product moment correlation coefficient for some data. Now obviously it's possible to do that, but it's not on the A-level course. You're not expected to do it. You'll never have to do any of the calculations to do with it actually calculating what the product moment correlation coefficient is. They will just give you it for some data, as they have in this question here, but we'll come to that bit in a moment. So first notice that in the question Maria is only interested in testing for positive linear correlation. So this is a one-tailed test, and our reason is that she's only testing for positive correlation. Nice simple mark there for part one. Now in part two, we first need to read this paragraph here. I've spotted that she's recorded the height and circumference of a random sample of 10 trees. It's trees of a particular variety as well, and it's in a particular wood near where she lives. And there we're given the correlation coefficient. So that's pretty strong positive correlation. So probably that will amount to evidence that there is positive correlation between height and circumference of this particular type of tree in this wood. But remember that the whole point of this test is because you could go out and measure any 10 trees anywhere, their heights and circumference, and you might go back to your study and find that indeed there is correlation. But you're always going to get some. The chance of getting exactly zero correlation is actually very, very small. You're always going to get some correlation, and that's just random chance. So it could be that this 0.642, this fairly strong correlation here, is just completely arisen by total fluke of the particular trees that she happened to select randomly. So the idea of this hypothesis test is to see, is this strong enough for us to say, yep, this is evidence? Or is it just, okay, it's positive correlation, but it isn't strong enough positive correlation for us to say that there's probably a trend? So that's the number we have to compare to something in this table. So before we go to that table, let's set up our hypothesis test. So we first need our hypotheses. So with hypothesis tests for this correlation coefficient, your H0 is always going to be that there's no correlation, i.e. that the correlation coefficient is 0. So that will always be the same for H0. Whereas H1 will either be greater than 0 or less than 0 or not equal to 0, depending on whether it's one-tailed positive, one-tailed negative, or two-tailed. This one is one-tailed positive. So our alternative hypothesis is that the product moment correlation coefficient for the population is positive, that there is positive correlation in other words. Now, in stats, don't forget, whenever you define a new variable, whenever you use a new variable, you have to define it. So we have to say what rho is, and you lose a mark if you don't do that. So I've written where rho is the linear correlation coefficient in the population of trees. I probably, to be honest, don't need the word linear there. I could have written where rho is the correlation coefficient in the population of trees. Now you need to mention the word population there, and ideally you need to put it in context as well. So I've just written the words of trees, just so that it captures the fact that this is a contextual situation about trees. Now, we need to work out which value to take from the table. So we've spotted already that the n is 10, and it's a one-tailed test, and it's a 2.5% significance level. So looking at the table, it's clear that that's the number that we want. And then we need to compare very clearly, explicitly compare the value in the question, 0.642, with the value you've just read from the table, and it's bigger than it, so it's strong enough correlation for us to reject H0, and then a conclusion in context, just to finish that hypothesis test. So evidence that there is positive correlation, and then put it in context, between height and circumference of trees of this particular variety. And I've even also written in this particular wood as well, because we don't know whether this finding extends to other woods. Which leads us nicely actually into part 3. Give 2 reasons why it would not be appropriate to use Maria's results to draw a conclusion about all trees of this variety. Well, there are 2 reasons here. Notice it's 2 marks and it's 2 reasons. It's worth noting that the sample size is very small. Really, you're just looking for reasons why it's just an insufficient study that Maria's done. So small sample size, and then something about the fact that it's she's only tested in the woods near her house. Notice it mentions of this variety in the question, so we can't say here that our reason is it might not extend to all trees, and that's not the point. It's already acknowledged that it'll only possibly extend to this variety, but the point is she's only done it in the wood near her home. It says here, the wood near her home. So I'm going to say correlation found in this wood might not be found in other areas. So that's that. And just before I finish, I will mention if you were doing a one-tailed test for negative correlation instead, or you were doing a two-tailed test and the value that was found was negative, in both of those situations, your comparison that you do here will be significant, i.e. you'll reject H0 if your experimental value is less, because you still, let's say the value in the table was still 0.6319, but if this value here was minus 0.65, then really this tells you that the critical value really is minus 0.6319. Notice that all these are positive always. So your critical value would be minus 0.6319, and if this was minus 0.642, say, that would still be a significant result because it's a stronger correlation. Negative 0.642 is a stronger negative correlation than negative 0.6319. So you're still kind of looking for the bigger number, really. Ignoring the negative, you're just looking for the bigger number. If your experimental value is bigger than the number in the table, then it's significant and you reject H0. Thanks.